Good morning to one and all. Today topic is high voltage DC transmission introduction. High voltage DC transmission is an interconnection of AC and DC transmission. That means it employs both AC and DC system. The purpose of this transmission is whenever we have to transmit bulk amount of power over a longer distances, and its advantages are more compared to the HVAC transmission system. HVDC transmission system is cost effective and it supplies large amount of bulk power over longer distances. There are some limitations of HVAC transmission system. The limitations are: first one, stability problem, reactive power loss and Faraday effect, and power control is not possible in AC system. That means it is somewhat complex in power control in AC system. But if you use HVDC system, the investment cost is lower and power controllability is easier, and here asynchronous interconnection is also possible, and we can transmit the power over longer distances, water crossing and underground cables also we can transmit the power. And if you observe this graph, here HVDC allows transfer of power between grid systems. These grid systems are running at different frequencies. One is operating at 50 Hz, another power system is operating at 60 Hz. That means two power systems are operating with two different frequencies. This is called as asynchronous interconnection. Asynchronous interconnection is possible in HVDC system. That means it improves the stability and economy of the grid also, and it improves the voltage utilization rating also. And next method and working. How HVDC system works. Here HVDC transmission system uses converter station. That means here we are using two converters. One is placed at the sending end, another one is placed at the receiving end. And here we are using the thyristors or mercury arc valves for conversion of AC to DC. At the beginning, the system converts AC to DC, and at the receiving, again the system, HVDC system is convert the voltages into the HVAC with the help of inverter station at the receiving side. And this is the HVDC transmission system diagram. See in the diagram, the wind power generates power, and that will goes to the AC transmission line, and the transmission line, from this we can receive the AC power. That AC power is converted to the DC with the help of AC to DC converter, and that DC power is transmitted to the another station, DC to AC converter station, with the help of HVDC transmission line. So from this we can say that HVDC is interconnection of both AC system as well as DC system. That means HVDC transmission system consists of both AC as well as DC. And at the receiving end, again this AC voltages will be again converted to the, again it goes to the distribution line. That means consumers. So at the consumers are nothing but here the receivers. Here at the consumer end we have to use the step down transformers only. We are not using any step up transformers because the devices are damaged at the consumer side. And next one, Here the components of HVDC transmission system are shown in the diagram. If you observe the diagram, there are main components are converter station, smoothing reactor and AC filters, DC filters and shunt capacitors. Here converter. So the main purpose of converter is to convert the AC current to the DC current and DC current to the AC currents. That means each converter will operate either rectifier station or inverter station. So that's why the name is converter. So we can't say this station as rectifier station or inverter station. That station should act as a both rectifier and inverter. So here we are using 12 pulse bridge converter is used in the HVDC system. That this 12 pulse bridge converter is formed by connecting two 6 pulse bridges in series. And next one, smoothing reactor. The purpose of the smoothing reactor is it removes or reduces the steepness of the voltages and sudden rising of currents from the DC line, and it smooth the ripples in the DC current, and they also decrease the harmonic voltages and harmonic currents in the DC line, as well as the smoothing reactors limits the fault currents in the DC line. And third one is DC filters and fourth one is AC filters. So here the filters are classified based upon the supply AC filters as well as the DC filters. Here the AC filters are used to eliminate the AC harmonics in the AC system, as well as DC harmonics are used to eliminate the DC harmonics are generated in the DC system. If you are not eliminating any harmonics in the system, it will definitely causes the interference in the telephone lines, and due to the presence of these harmonics there are power losses in the machines. That means the system is unstable. That means instability of converter controls. So it is necessary to minimize these harmonics by using AC filters as well as DC filters. Sometimes we are using high frequency filters also we are using. The purpose of these high frequency filters are, if the frequency range is very high, that means 20 kHz to 490 kHz, this high frequency is nothing but carrier frequency. So due to the presence of this high frequency, the converters may produce electrical noise in the system. That means they generate radio interference noise. So that's why these high frequency filters are used to minimize this noise and interference with the carrier communication power lines. So these filters are placed between the converter transformers and the station AC bus. And next one is shunt capacitors. Shunt capacitor purpose is it provides the reactive power. Reactive power is necessary for satisfactory operation of the converters. And here we are using the back-to-back DC link. In the coming slides we will see what is back-to-back DC link. But it is back-to-back DC link is nothing but it is one type of HVDC link. This is about the components of HVDC transmission system. And next one, what is the transmission medium? So here we have to transmit the bulk amount of power over longer distances. For that we are using one transmission medium is nothing but here the overhead line. So the overhead line here we are using bipolar. So this bipolar, this is called as bipolar link actually. It is one type of HVDC link. So bipolar in the sense it means two conductors having different polarities. So generally these cables are used for submarine transmission, and HVDC underground or submarine power transmission also possible. So these are the types of HVDC links. First one is monopolar, second one is bipolar, third one is back to back, and multi-terminal system, tripole system. So among these available HVDC configurations, mainly we are using the bipolar HVDC link because it gives the reliability. That means reliability in the sense here continuity of the power supply is possible to the consumers. So that means consumer will satisfied with this bipolar link only. In the next class we will discuss what are the various types of HVDC configurations in detail. Thank you.